Can you hear me now?
Yes, General, very well. Thank you so much.
Yeah.
Wonderful.
Okay.
All right, go ahead, sir.
Okay. Thank you very much, and sorry for the technical faults. However, let me start. So, Secretary to the Association of Disaster Risk Management Professional at RIM, Dr. Chandana Sirivardhana, then President Dr. Ananda Malotantri, resource personnel, panelists, and participants. Good evening for the participants in the Asian region, and good morning for participants in Europe. I wish to thank ADRIMP and Huddersfield University for giving me this opportunity on a very timely and pertinent topic. Lightning is one of the oldest observed natural phenomena on Earth. Thunderstorms occur everywhere around the world throughout the year as a recurrent phenomenon. Lightning is one of the most disastrous phenomena in the world. And as we are experiencing intense lightning activities in this season during this time, this webinar is very timely. Disaster Management Center, commonly known as DMC, is mandated to work on multiple disasters and risk reductions through the Sendai framework for DRR. Hence, we have given high priority to lightning protection in Sri Lanka. Lightning strikes can produce severe injuries to humans as well as destruction to infrastructure and property. As per records, around 240,000 lightning incidents or lightning strikes happen globally each year. The annual global death toll is approximately 6,000 as per records. According to our disinventor data, an average of 40 people dies every year due to lightning strikes in Sri Lanka. This is as per our disinventor data. And mostly those who are engaged in outdoor activities such as farmers, field workers, fishermen, then children, of course, and sometimes the players are more vulnerable to lightning strike. Reported deaths, damages, and casualties due to lightning strikes in rural areas on using electronic and electrical appliances are more as compared to urban areas, as mitigation mechanisms such as lightning protection systems are installed for their residences, factories, and offices in most of the urban areas. Further, geographical features like terrain, soil types like soil conductivity also enhances the impacts of light. And according to the latest statistics and surveys, it is revealed that the people who do not have proper shelter, particularly with galvanized sheet roofs, are more vulnerable for the lightning, and it causes more casualties. And EMC is committed to reduce the deaths due to disasters 50% in 2030, according to the SFDRR. In the process, DMC is prepared to pay more support for research and case studies for better understanding of the science and potential approaches to minimize the lightning impacts, including injuries, deaths, and property loss. This context, this webinar is in the right time, right direction, and very good opening an opportunity for all of us who are here as panelists and the members who are listening to enhance our knowledge, share our experiences, and join up with the team for the final goal of Safer Sri Lanka. And the webinar will explain in detail the science of the development of thunderstorms, lightning, climatology in Sri Lanka, and the places where highest lightning is observed using latest data, and finally discuss the options available for lightning protection. Therefore, the webinar will be useful for the scientists, policymakers, maintenance engineers, communication authorities, business communities, as well as the players, and most importantly, rural communities and villages. Of course, we can carry the messages. It's very important for everyone to know where they are, where the danger is, and how it will strike. So finally, I take the opportunity to congratulate the Association for Disaster Risk Management Professionals for the timely topic and wish to propose a dream to organize similar events on different issues related to disaster risk reductions in the future. I'm sure you will have much more to come in the future. With the lockdowns, of course, we never stopped working, and we have been working together as one team for last previous few months. And thank you very much. And I wish you a productive webinar and a pleasant evening. Thank you.
Thank you very much, Major General Sudhanta Ranasinghe, Director General of the Disaster Management Center for Evaluation is figured out. Dr. Shiromi, are you ready?
Yeah, I'm ready, yes.
Okay, let me give me a second to introduce you. Dr. Shiromi Jayawardena is currently the Director of Forecasting and Decision Support in the Department of Meteorology. She has been in this meteorology field about 21 years. Dr. Jayawardena got his bachelor's degree in physics from University of Peradeniya, and then master's degree in meteorology from University of Hawaii in Manoa, United States. And also she completed a postgraduate diploma in satellite meteorology and global climate in India. And she holds a PhD from the Open University of Sri Lanka. Dr. Shiromani is well known in the professional circle on climate related work, and she is a visiting researcher for Center for Australia Weather and Climate Research. And also she is working on many areas on climate variability, interseasonal vulnerability, tropical cyclones, storm surge, climate change, seasonal forecasting, heavy rainfall events, Asian monsoons. So it's a wide variety of experience Dr. Shiromi Jayawardena carries. So today we are very lucky to have a very technical presentation presented in a very simplified manner. Dr. Shiromani, that's all yours.
Thank you, Dr. Ananda, for very interesting, nice introduction. Good afternoon. Let me share my. Okay, so I am going to talk about lightning climatology today, and I would like to acknowledge severe storm warning services for Sri Lanka project funded by Finland government, where they have provided us that GLD 360 very high resolution lightning data set for 4 years. Some of my work, I am going to present that work also. This is the outline of my presentation. So first, I would like to talk about global and regional aspects of lightning climatology, and then Sri Lankan aspects in terms of annual, seasonal, monthly, and hourly distribution of lightning in Sri Lanka. And so this is the global map. So we can see that especially over tropical region as well as mid latitude region, there are some high density lightning occurring places. Like in Asia, we have Bangladesh and Northwest India and Sri Lanka, and this African, Central Africa, US, and South America also. There are some places where we get very high density lightning activities. So when it goes to our region. So we can see very this I got from Nag et al. 2007 his research work. So he has chosen 4 areas where we get high lightning density in South Asian region. One is Bangladesh, Kerala coast, and Sri Lanka. So in Bangladesh, annual fatalities goes around 250. India, in recent publication, it shows more than 2,200, and in Sri Lanka, it's around 50 deaths per year. On average, there are 64 million lightning strokes per year reported by GLD 360 data over the South Asian region. And in seasonal variation of South Asian region, we can see pre-monsoon, March to May, high lightning activities. And in monsoon time, June to September, we can see high density of lightning activity over Bangladesh as well as Northwest India. And post monsoon, October, November, so we can see over Sri Lanka and Kerala coast. And during winter, so we can see a very less amount of lightning activity over South Asian region. So the diurnal variation of day, throughout the day, how the lightning activity distributed. So we can see over Northwest India, it's during late afternoon, and Kerala late afternoon and early morning, and Sri Lanka, it's majority occurs during late afternoon. But Bangladesh, we can see throughout the day lightning activity. So this is actually recently we got, because Mr. Abesing's presentation we couldn't get through. So I just wanted to briefly say something about this, the cloud which brings lightning. So we call it cumulonimbus cloud. In generally, the base of the cloud is 500 meters from Earth's surface, and it goes up to vertically, it extended up to 15 kilometers sometimes. So this overshooting tops, we can see it clearly over in this cloud visible image, and here we can see the associated lightning brought from this cloud. And this is actually yesterday, we know Colombo area, we got very heavy lightning as well as strong, very heavy rainfall. So this is how the lightning activity distributed from the GLD 360 data. And this is the Kalpana visible image. So where we can see these clouds. And one of the interesting thing is this cumulonimbus clouds. There are a lot of activities going on, very strong updraft, upward wind and downward wind, and there are a lot of ice particles, grouples, and super cool water droplets within this cloud. So that's why this electric charge also occurred in this cloud. So this is the annual lightning stroke densities. There are 2 maps here. One is using that GLD 360 data from 2015 to 2018. And this is using annual lightning frequency using thunder days. According to the World Meteorological Organization, if we heard thunder at least once a day in particular location, we consider that in that location, we consider it as that day as a thunder day. So using that data from our 20 station from 1961 to 1990, the annual lightning frequency map developed. This is actually using this GLD 360 data, and it's considered total flashes, not only cloud to ground flashes. Here we consider cloud to cloud as well as cloud to air flashes also. So we can see 3 peaks in this map. One over western part of the country, where southwestern part, especially western foothills of central hills, we can see very high peak over here. And then this area is in the north central province. So this area is, I think we have to pay much attention, because this is the where we had a lot of paddy cultivated lands. So most of the farmers, they do their daytime work in this field, so they can be victimized for the this lightning activities over this region. And again, southeastern foothills of central hills also, we can see another peak. So this is based on, actually this is very high resolution data, and this is using the 20 meteorological stations. So we can see this western part and the southeastern foothills, that two peaks, but we cannot see this peak over in this map. And so when we overlay this map in a digital elevation model, so we can clearly see how the orography effect, the mountain effects play in this lightning distribution. So this area, the orographic influence play a major role for the development of these clouds. And this is probably convergence of sea breeze coming from this region and this region. I'll explain this later. So this is the annual variation of lightning strokes. So we can see year-to-year variations. So we can see this least lightning activity occurred in 2015, and very strong activity we can see in 2017 and 2018. So this lightning higher density peak over this western part of the country is visible in both all three years. But intensity over this north central province is some years it's strong, and especially 2015 we cannot see it. In terms of districts, so we found the maximum lightning occurrence in Kegol districts, then followed by Gampaha, Kalambu and Kalutara. Least activities we found over Jaffna and mountain tops, Nuwara and higher elevation of the mountains. And this is the year-to-year variation. So on average, 3 million strokes per year occurred in Sri Lanka. So compared to that, if we consider this as average, so 2015 and 2016, we can see less lightning activity compared to 2017 and 2018. So we can see some increase in trend, but keep that in mind. In this data set, we didn't have January and February data for 2017. So if we had that data, maybe 2017 will be higher than 2018. So this is the seasonal variation. So we have 4 seasons, 2 monsoon season, and transition period between these 2 seasons we call intermonsoon season. So we can see higher lightning activity during intermonsoon season. Highest lightning activity we can see during the first intermonsoon season. So especially March, April, we can see the annual lightning density map actually dominated by the lightning activity occurred in first intermonsoon season compared to the season. And in second intermonsoon season, October, November, we can see widespread lightning. Here we can see only western parts of the country has more lightning, but in second intermonsoon we can see widespread lightning. And southwest monsoon, most of the lightning concentrated to the lee side of, because wind is coming from this side. So the opposite side, we can see more lightning activity. So least lightning activity occurred in northeast monsoon season from December to February. So most of the lightning activity concentrated to the southwestern parts of the country. So this is also the year-to-year variation. So we can see this percentage. So first intermonsoon contributed 50% of the annual lightning, and then second intermonsoon around 25%. Rest coming from the major 2 monsoons. So this is the district-wise lightning during 4 seasons. So we can see first in the monsoon, where western parts got more lightning activity, as well as the central north central parts. And in southwest monsoon, we can see most lightning activity concentrated in Vaunia, Mullaitivu, and that area. So second in the monsoon, we can see mostly over Gampha, Kalutara, and western part, as well as Matale, Kurunegala, and northwestern parts. Northeast monsoon, it's very less lightning occurs. They are more concentrated over to the western parts, especially southwestern parts, Kalutara, Colombo. Gampha also a little bit less compared to the other seasons. So this is the monthly variation of the maps. So we can see very clearly month of April is the dominant month for the lightning activity. So we can see annual peak if we can see that western parts where we can see the 3 peaks. So this can be clearly seen all months, even in 2015. So May also we get some lightning activities, and March, and then October, September, October, November, it's more concentrated into the southwestern parts of the country. But this year, I think we experienced more lightning even in November. October, we didn't get much lightning this year because of the La Nina conditions. So this is the monthly variation and comparison with the lightning thunder days based on the lightning from thunder days. So we can see January, February, least lightning occurs. So they also have that. And so this is April, March, April, and May. And June, according to the thunder days, it's more activity compared to our data, because our this GLD 360 we have only 4 years, so maybe that is one reason for that. And then this is for June, July. So we can see June, July more lightning concentration to the northeastern parts, and then widespread lightning activity in September, October, and least again in December. So this is another paper from Dr. Sonnandara, 2015. So he also used lightning thunder days and then converted into the this lightning density using Ericsson formula, and where we got more lightning over this Ratnapur area, because I think we have one station here. Kegol we are missing because we don't have a station over Kegol district. And this is the monthly lightning variation of the lightning strokes. So we can see these variations. Highest is coming from month of April. It's more than 30, in general 30% of lightning activity coming from month of April. Then from October, it's around 15, and again somewhere around 15 in May, and 12 around March. Rest of the months, we didn't get much contribution from the rest of the months. So we can see 2 peaks dominated during March, April, May, and other one September, October, November. Sorry. So this is the our lightning activity, like other papers. So we found that late afternoon maxima over Sri Lankan region. So even though there is a year-to-year variation, that maxima every year we can see that late afternoon maxima, especially peaking around 3:30 to 5:30 p.m. So this is due to most of the lightning activity in Sri Lanka occurred due to the land surface heating, especially when we consider month of April. So there's a no predominant wind flow over Sri Lanka. So light winds and the sun's overhead positions also will be over Sri Lanka during first 2 weeks of April. So that also brings more heating, and that is the reason why we got more lightning activity in month of April. So the possible causes, like I mentioned earlier, so we can see this sea breeze and the surface heating and mountain influence upward wind during daytime bring form this cloud and bring lot of lightning over this region. And the peak over North Central province is due to convergence of sea breeze coming from this northeastern parts and northwestern parts converge over here, and daytime heating will bring a lot of clouds over there here and lightning activity. So during monsoon season, we can see lee side, where the opposite side of the wind direction, we get more lightning. That is due to this convergence from ambient wind and sea breeze. Convergence brings lightning over that lee side area. So there are other possible causes for lightning activity in Sri Lanka in other than sea breeze convergence, intertropical convergence zone, where the northern hemispheric and southern hemispheric wind meet that the line. We call it intertropical convergence zone. When it's over Sri Lanka, we got more lightning, and like orography, where we get upward wind due to daytime heating. And then easterly waves also bring lightning over Sri Lanka. So this is actually Diana's strength of South Asian region. I got this from Johnston 2015 paper. And according to him, the daytime and morning and evening precipitation difference. So we can see most of the country except this part and Bangladesh, they have less Diana strength, but that is negative actually, because their daytime morning rainfall is more than evening rainfall. But in Sri Lanka, we can see evening rain is more compared to the morning rain. So there's another possibility of this, like I mentioned earlier, the orography effect, and where daytime upward mountain winds also aid to the sea breeze for formation of these clouds. And sometimes this nighttime downslope wind, if the ambient wind is opposite direction, when these two winds converge, so we even nighttime over the these foothills, we can get some lightning activity. And then there's another question maybe you have, because even though Sri Lanka it's an island, all places within this get peaks. So that is one thing is the coastal orientation. So shape of the coast. If there's a cape, so we can see the converging of this sea breeze, and if there's a bay, it's diverging. So that kind of irregular shape of the coastline also is reason for the spatial variability of lightning maxima over the country. So this is the summary. Highest direct mean lightning densities occurred over Kegol district and Gampra districts around, that is 130 flash per kilometers per year. This is considering all flashes, not only cloud to ground flash, considering cloud to cloud and cloud to air flashes also. Gampha district become the next, and Colombo, sorry, the highest coming from Kegol, and then followed by Gampaha and Colombo. On average, 30 million lightning counts per year reported during from 2015 to 2018. And maximum lightning occurs from first intermonsoon season is nearly 50%. Then second intermonsoon brings 25%. So the majority is coming from two intermonsoon seasons, and least activity found in northeast monsoon. So the reason is during intermonsoon season, there's no predominant wind flow over Sri Lanka, so prevailing light winds and the sea breeze circulation and the surface heating brings this, and orography effect counts the lightning activity, majority of the lightning activity in Sri Lanka. Thank you very much.
Thank you, Dr. Shiromani Jayawardena. Thank you for this presentation that's full of technical material, but you made it so interesting, and you presented in such a nice way that most of us could understand it. So thank you again. So we have the next presentation.
Thank you.
Thanks, Shira. The next presentation is actually a combination of the first presentation from we missed from Mr. Abhay Singh, and then the third presentation for the day. It will be done by Engineer Kumar Singh. Engineer Kumar Singh is the former Chief Electrical Engineer in the Department of Meteorology, and presently is working as the ICT and instrumentation experts in a World Bank project in Bangladesh. And also he's a freelance consultant on lightning protection and executive committee member in the South Asian Lightning Network, CELNET. Engineer Kumar Singh obtained his BSc Engineering and Masters in Engineering degrees from the Technical University, Jose Antonio, Havana, Cuba. And he holds a postgraduate diploma in satellite communication from Space Application Center, Ahmedabad, India. Engineer Kumar Singh has served more than 27 years as an electronic engineer in the public sector, and more than 6 years as a production engineer and maintenance engineer in the private sector. So he's widely experienced in all the standards on lightning protection, SLS standards, and he's also a member of the Standard Preparation Committee for SLS 1261. Currently, he's a technical advisory member for lightning protection at Arthur C. Clarke Institute of Modern Technologies in University of Moratuwa. He's a committee member for the preparation of the guidelines for communication towers, telecom regulatory commissions under the Telecom Regulatory Commission in Sri Lanka. So the presentation will carry some of that experience and some of the techniques that we can adopt. He has designed more than 100 lighting protection systems around the country in various places. So Engineer Kumar Singh has agreed to combine the first presentation and continue his prepared presentation. So we will have the second and the last presentation before we have the panel discussion today. One request, if you have questions coming from Engineer Kumar Singh's presentation or from the earlier presentation from Dr. Shiromani Jayawardena, please enter them in the chat box so they can probably, we can do a little bit of preparation and we can answer them during the panel discussion time in the early part. So with that, Nuwan, all yours. Thank you.
Thank you, Dr. Ananda, for introducing me. Actually, let me share first Mr. Abhay Singh's presentation. So actually, this is a very critical situation now. Suddenly it happens, technical failure that Mr. Abhay Singh cannot reach to you. But anyway, I'm ready to just summarize what Mr. Abhay Singh is supposed to do. So regarding the physical characteristic of lightning, so as you know that lightning is a massive field, I must say. So it has a lot of fields, so, you know, so it includes...
Nuwan, we cannot see.
Beg your pardon?
We cannot see the slides. If you are using slides, I believe you are.
Yes, I share. Hello? Hold the line, please. Just hold on. Just hold on for a moment. Now it's shared?
Yes, yeah, the presentation on lightning protection can be
Yeah,
seen now.
so-
Thank you.
Yeah, it's okay. So as I mentioned you that there are different areas, so the fields of lighting related activities, or the fields. So for example, the physics of lighting is one of the fields. So the structural protection, I'm going to explain later on, and the surge protection and the grounding and bonding, the lighting research, the mainly what Dr. Shiromani was involved, and many of you may be involved, and including Mr. Abesinger, and lighting detection and prediction. That's one of the most important part as well, and the injuries and human safety, the insurance schemes, and so on. So there are various fields. So I think most of the lighting community in the world, including Sri Lanka, parts of the world, they all are working and all to the benefit of the people. So I think some of the presentation going to move fast because already Dr. Shiromani has showed it. So this is what I have taken from USA, the insurance companies. So as you can see that 21% of all these claims are coming from due to lightning defects. So case of Sri Lanka's scenario, so we don't have such a database, but the very recently under Fire Act, under the fire scheme, the insurance of Sri Lankan insurance entities, they have started their schemes, but we don't have any statistics so far. So I think within another next 5 or 10 years time, we'll be able to present this. So as we have taken from Department of Meteorology, the data collected by the Department of Meteorology since 2008 to 2019. You may have seen that number of reported deaths during this past. So we may have seen here since 2008 up to 2019, in 2000, so 51 reported as death. So apart from deaths, there are partially injured people, paralyzed people we can find, but it's not mentioned here. So as per now is the average, there are about 25 or 26 people per year that they'll lose their lives due to lightning. So let me explain a little bit, though I'm not a meteorologist, but as I am working with Mr. Abesinger and the other community, so let me explain a little bit of how this cloud formation, which is the main cause of lightning. So what is this? So as you know that energy for us is coming from the sun. So that is the main source of energy. So what will happen? These are the necessary ingredients for the convection. So which Dr. Shiromani mentioned about the convection. So these are the three main ingredients for the convection to be taken place. For example, the moisture, which I say is the fuel for the thunderstorm, and instability, which I say the engine. So does the atmosphere support in the rising motion of the moisture, and the lifting mechanism. So it's the trigger part. So when these three conditions are there, so then only the convection is taking place. So these are the process. So these are the normally, so this is the early morning and also the midday and the mid-afternoon. So as Dr. Shiromani explained, these are things I'm not going to explain further, not to repeat these things. So this is the cumulonimbus cloud. So as Dr. Shiromani also showed, that normally it rises up to 10 to 12 kilometers. Sometimes it goes up to 15 kilometers of height. And the base we'll find from the earth is about 500 meters. And the width is, the radius is about say 2 to 5 kilometers, which covered almost maybe the Sri Lankan scenario is about 2 or 3 villages sometimes. So this is the cloud which brings, we call it CB or the cumulonimbus cloud. Okay, so what will happen? Let me see. So the charge separation and the cloud formation, how it happens. So let me explain. There are a lot of arguments going on this about this charge separation. But let me just point out, Mr. Abhay also mentioned here, it's a combination of temperature and rapid upward air movement that produces a mixture of supercooled cloud droplets or the small water droplets below freezing, and small ice crystals and soft hail. So the updraft carries the supercooled cloud droplets and very small ice crystals upward. And what will happen? So these two parts, when it rises and it goes up and down, so it will collide in between. So the difference in the movement of the precipitation causes collisions to occur. So when the rising ice crystals collide with the droplet, the ice crystals become positively charged. That's what normally we think the ice crystals are positively charged and the droplet are negatively charged. So that's how mainly the charge separation taking place, right? So we have now the positive charge and the negative charge. So let me explain in the further way in little bit of animation. So when the electric, normally, as you know, air is a very good insulator, right? So normally, until such a situation, when it becomes, the charge is over 10 to the power 6, 3 megavolt per meter. That is the electric field. When it's passed to that, it is not again persist as an insulator. So it then it start discharging from the air. So still you can see now the cloud start discharging from this. Now here you can see the upper part here, the positive charges, and here the negative charges. And actually you can see the real scenario. If you take the vertical aspect of the vertical part of the cloud, you can see negative charge will be in the middle and the positive in the top of there, and again the small positive charge on the base of the cloud. So what will happen when the charge start discharging from the negative side, and it will not come directly, it will come as a step, we call step leader. So step, like for example 20 meter or 50 meter step, and then pause and then stop, and then again and again comes like that. So what will happen when it reaches to the earth? So earthbound object, including the human beings, animals, trees, structures, or whatever, they start reacting this. So you can see now here the negative charges are coming towards the earth, and then earthbound objects like here I have shown here the structure, then the positive charges will react to these negatively downward charges. So there are many charges. So what will happen? Though there are many charges, so we call this positively charged, we call it streamers. These streamers and these negatively charged step leaders then meet together, and this will create a path to the earth, pass this huge energy of current to the earth. That's we call the lightning. This is the normally we call the return stroke of this light and discharge. This is very important. So these are the three main parts of the lightning strike. As I explained you, the negatively charged or the positively charged can be also. So a step leader and then return stroke here. The streamer is coming from the earthbound object. These are the three main parts. So remember, for my next presentation, I will use this step leader, which is coming like a 50 meter more or less steps towards the earth. So this is actually the charge distribution in a cumulonimbus. That's what I told you. You have a negative charge here, the positive like that. So actually, the 75% of this discharge process, so we can see, we call cloud discharge, because these are within the cloud, we call infracloud, cloud discharge within the cloud, intracloud, and the cloud to the next cloud is we call cloud to cloud. So 75% of this discharges are cloud discharges. So, but these cloud discharges are not merely harmful to the human beings, except the aeroplanes and all in some instances. But this 25% what we talk about, we call the ground discharge or the cloud to ground discharges, will bring the damage to the people and the property. So lightning facts, globally there are, I think these parts Dr. Shiromani explained well. So globally there are about, say, per second 100 lightning strokes per second. And lightning, one flash can constitute, the one or more lightning strokes. And also the duration of a stroke is about 1/5 of a second. Remember, this is very, very fast phenomena. So you cannot even think it's a flash. In a flash it occurs, and total energy will disperse to the earth, passing through a human body or a structure or whatever. And the total energy release is about 40 gigajoule, and temperature rises to 50,000 degrees Celsius. Lightning is near by to about 10,000 Celsius. So you see these are the physical the features of these lightning. Right. Let me see you now because of the lightning strikes. So what are the impact of this? This is the most important part of today as far as disasters are concerned. So now the first one I may say, these are the direct lightning. This is, as everybody understand, that direct lightning as a huge lightning current brings as a steps, as I explained you a little bit earlier, it's coming like this. And if it hit to a human being as a direct, but definitely, so we will see definitely the people, that man, a human being will be death. So second, like I may say, after this direct lightning, you can see the side flash. So instead of, it hit a human being, it will hit to a nearby structure, a tree. Now here, in the case of the tree, it can be a communication tower, for example. So it will hit first to the tree. So what will happen? So from tree to the earth, there's a huge difference of voltage, potential difference. So because of that, as I already explained, what is the air breakdown situation? That is 3 megavolt per meter. That is the electric field. So which it pass to, it can even, the voltage difference between the height of the tree and the earth is very high. So it can occur, and it will, can flash to the man here. We call the side flash. This is, in Sri Lanka and on this part of the world, even Africa, and even India, Indian subcontinent, Pakistan, Bangladesh. So we'll find a lot of fatalities due to this side flash. Okay, the third one we call the step voltage or touch potential. The touch potential. So the touch potential is where, if you touch, normally when the lightning occurs, and normally the meteorological authorities in the world, including Sri Lanka Department, they always issue the warnings not to go outside, be inside, right? And also you should not touch the metal objects because of this reason. What happened? If you touch a metal object or a whatever, say metal railing or a window frame or with a metal thing, so because of this lightning, the huge current, so close environmental is inductively affected. That effect is there when you touch the thing. So there will be a voltage difference between this where you touch and your foot, and there about here, and in this case is 5 kilowatt difference. So what will happen in normal electricity? We know that the current to be passed, there should be a voltage difference. So that's why there's a voltage difference between the man's hand here and the earth. So then there will be current passing through, it will get damage to their body. Okay, the fourth one is the step potential. So this is also similar damages can be very popular in Sri Lanka and Indian subcontinent, especially this step potential will make a lot of damages, like side flashes as per our observations. So what is actually, so normally this huge lightning current theoretically should go into the earth, but it should not happen. That depends on the earth's surface earth and what is the structure of the, if the earth resistivity and the resistance is so high, so instead of going inside, it will go on the earth. So what will happen if someone touches, some hit their foot, the difference between his one foot to another, there will be voltage difference, so pass into the one foot to other, and the man will get feel or a hit maybe that depending on the severity of the current here, he will get damage. Okay, another thing that I will explain in my next presentation, so I will not move this fast. So these are, as you know, that we call normally these safe locations. So as a general science, and in childhood, we studied that normally the close metallic object, the inside the object, the metallic close object, the electric field is almost zero. So, I mean, applying this theory into this thing, so all these, the vehicle, train, inside a train, inside a bus, inside a plane, inside house, I must say the house that nicely built, or properly built house, not all houses, and are safe locations. Whereas the unsafe locations, I can, the bicycle, so, and the use in trucks and all, the horse riding, the boat riding, and the open vehicles, these are not supposed to do once the lighting, is in place. Okay, thank you very much for this is Mr. Abhay Singh's presentation I just grabbed. Let me now switch on to my original presentation. Dr. Ananda, I hope you can hear me.
Yes, very well, Nuwan. Go ahead. Thank you very much. Wonderful.
Okay, now I'll come to the point of original presentation is the lightning protection in a nutshell. Why I use the word nutshell? Because this is very large area. You cannot talk within 20 or 30 minutes. Because originally, I must say, let me remind you that we originally organized a workshop on 17th October, one-day workshop to have the entire disciplines, so the lightning physics and lightning structural protection and the power line protection and communication line protection together with Mr. Abhay Singh, myself, and engineer LSP Karunaratne from Sri Lanka Telecom. But unfortunately, due to this pandemic situation, we could not have that. That is organized by ADRIMP, thanks to Dr. Malvatantri, Dr. Chandana, and also Mr. Premalal, the former DG. They are the organizers, and Mr. Anuka has done a wonderful job, I must say. So that's why I put nutshell, because you cannot, everything I can explain, but you have to excuse me. But any question you can raise and you can write to us. I and myself and Mr. Abhay Singh and Mr. Karunaratne, we are ready to answer you through mails if you don't have time. Okay. So actually, so why we need a lightning protection system? That's, already know that lightning brings a huge current, huge energy, at which cause damage to the human as well as property. Now here I have shown you, here I'm not going to talk about the human, because as you know, the human is the first to be protected, no doubt about that. But what about the property? So here, at the point of the strike, the lightning generates a direct thermal effect that I explained you. What is the energy? It's a huge amount. It can be, the melting can be taken place, the fire can be taken place. So it goes by the electric arc. And thermal and thermodynamics effects induced by circulation of the lightning current. The blast effect, the shock wave, and the blast areas are produced by heat and the expansion of the air. So you may see now, this is one of the examples I just showed you. So in case a huge energy is coming from these step leaders, which brings a huge energy. Normally we believe is energy is about 200 kiloampere. It brings, for example, right? So I will use that figure as well for the protection methods. So protection against, as it brings a lot of energy and a lot of currents, so the protection against the direct effect of lightning is based on the intercepting the lightning current and discharge to the earth. Now, we should find out the mechanism as the lightning coming like this, like a step leaders. So if we have a system here, right? If we have a system here, if we can block this, we can intercept this, and we can safely to the earth without damaging to the content of the house or the building or a structure, whatever, the human as well as the property. So that is the one side of it. But here you can see, because this building doesn't have such a system, so it will get a lot of damages. Okay, that is the one part, that is the direct hit. Now, what about the indirect effect? So why we need lightning protection system? Because of this also. Now we talk about earlier slide, we talk about direct effects. No doubt it's a huge energy, but what about this? Now you see, now there are, I have captured here 3 cases. Now here the lighting is coming to the building, whatever. So the first case, number 1 I brought here, and then number 2 and number 3. Now if you take the number 1, the case here, you see the power line, the service line is coming to the your structure of the building, right? So the direct lightning strike instead of the building, but to the power line, for example, here. Maybe it can be power line, it can be your television system or the telecom system or line or data line, whatever. But mind you, these lines can be entered, I mean, from the outside, the service providers to the building, or the lines going outside the building. The both things. We all, sometimes we forget, you know, there are lines going out now from the building. Now, the second scenario, so what happened? It is coming from the earth. Now, suppose you have an object here, for example, right? That object, suppose we have a tree here, you have a tower here, for example, and it hit there, and instead of going inside into the earth, so one portion going into the earth and the other portion passing on the earth. So that is part 2. That will affect your system. It can inject. I'll explain later on. And the third one is the induction effect or the conductive elements. That also maybe. So now, so these are the effects. So direct effect, you know, and the indirect effect. So the protection, statistical damages to the electrical installation and equipment is mainly due to the indirect effect. That's, remember that this is statistically is proof that equipment damages are mainly due to indirect effect. So we have to address both direct, indirect effect. Okay, now how do we, address this issue? So as you know, the topic is about the risk. So similarly, here also, you have to do a proper, a thorough assessment process. How do you do? Okay, of course, you have to conduct surveys. You have to, collect data. You have to go through the historical records like that. So you have to find out, for example, the nature of the structure. For example, if it's a mission critical, like for example, it's a TV studio or radio studio or the hospital, for example, or religious place, a temple or the church or the mosque or whatever, the mass gathering place, or the exposed area as well. All these things you have to take into consider. And the location is in the, Dr. Shiromani showed very well that the high density, light intensity areas and low density areas, not only for Sri Lanka, also for the other parts of the world, like, the India, in our parts, maybe in Africa, in Bangladesh or Nepal, for example. So we have to see what are the density levels of this country, countrywide. So depending on that, where your building is situated, you have to follow these maps, what Dr. Shiromani showed you. Is very important, and even our Mr. Abesing has prepared for Sri Lanka standard preparation isochronic level, right? Is the number of thunder days per year. So you can follow those things. So, and also we have to consider the number of occupants. How many are there, right? That depends. For example, if you take, for example, a school, the school children are many. So even the school is small. Situation is located in merely the mid-level of light intensity area, but because of the school children, you have to consider as give the preference for that. But if you take, for example, in case of radios, what we call the communication base station, they have only maybe unmanned or one person or two persons, right? So the number of occupants are very less, but still the property and the service provide to the people is very high. So that all depends on the thing. Okay, how do you calculate? So there are a lot of formulas. So I'm not going to show this presentation, and if we don't have time. So, but we don't use this nowadays, the formulas. We are using software. We have software. I'm using here IEC, International Electrotechnical Commission software here. There you can see the structures dimension you have to give, and structures attributes, for example, the risk for the physical damage, like that, the local environmental influences, and how the service lines are going. For example, the power line is going overhead, or the power line is going underground, etc. So many factors you have to input, and ultimately it will give you the risk whether to implement the lightning protection system or not. Depending on the risk level, we decide. Okay, now you know the lightning physics. Now you know the need of a protection after the assessment, of course. Now, how to, this is the important part. Now, how to do is very important. Now, there are many countries, including Sri Lanka, and India, and our part of the world, even Africa also, I know that some people use protection systems, but they are not up to the standard. So what is important today is follow the accepted lightning protection standard. I just showing you what are the internationally accepted and nationally accepted lightning protection standard in the world and the individual countries. I just grabbed some of them. You can see about 95% of the world are using the similar, the unique standard, which is called IEC, or International Electrotechnical Commission's standard. We call IEC 62305 standard. So in Sri Lanka, we have adopted, I was the chairman for this committee preparation, and we have adopted as SLS 1472. There are 4 parts, 1 to 4. And earlier we had SLS 1261. Abesing and I both took part for the preparation. Now, for example, in UK scenario, so UK earlier they used a standard called BS651. I did not mention because they are not using anymore now. They have adopted from IEC. They call BS-EN is normally called for the European community. So the BS for the British standard. So 623 is sort of a same standard we have seen. And India, earlier they have used their own standard. Now they have adopted from IEC 62305, IEC 62305. Also, sometimes, India still they are using national buildings, these guidelines. So the codes, we call National Building Code 2015. There's still some from them. You will see so many countries they use. But let me see you now. For example, in case of France or Spain, these 2 countries, there are about 5-6 countries in the world. They use this standard as well. We call NFC 17102. But if you come to they are also used in IEC 62305 standard, and in some places, some people use also NFC, the French standard, and Bangladesh own building code, Bangladesh National Building Code. But you can see here, 95% of the world, they are using IEC, or the IEC adopted national code. Okay, now hereafter, until the end of the presentation, I'm going to use this IEC 62305 standard. So what they say actually, so here, what happened, they divide into different zones. So actually, so what happened? So here you can see the zones are areas characterized according to the threat of direct or indirect flashes and full of partial electromagnetic field. So these zones are not, the bound. Just say no. These are actually hypothetical boundaries where the lightning can occur. For example, if you take this my left hand side, the same with the right hand side also. Now here, the possibility of occurrence for the direct flash is outside the building. That's what we call lightning protection zone 0A. Now if we come to the inside, here the occurrence for the direct lighting is a little bit less, but it's less actually, but influence is there. That's what I put gray color here. But if you come to inside, the direct lighting, if it is less, but the indirect effect, I explained you earlier, is there. So you have to consider all these things. So now what is the rule of thumb here? So these normally divide into levels. So these introduced and design rules are based on the lightning protection systems being able to protect maximum values. That is we call sizing efficiency. What does it mean? For example, I told you at the beginning that maximum lightning current could be 200 kiloampere, right? And so this particular thing, depending on the class of the protection level, we'll say the sizing efficiency, right? And the minimum value is, I tell you the beginning, as the lightning comes like a step leader, so interception efficiency depends on the minimum value of the lightning current. So both we play the role, the maximum and the minimum value. So very important thing. So you can see the lightning protection level 1 offers the highest protection level, but is high. The cost is high. But if you take the lightning protection level 4, cost is low, but offering a low level of protection. That's very important. Okay, let me now see similarly, so what are the different sources of damage? I already explained it, but let me just again, just to grab here. Now here the first case is the first source is the hit directly, and the second source is it hit nearby, not directly. The third one, it hit to the service line, maybe the power or datacom line or telephone or antenna, whatever. And the fourth one, instead of hitting the service line, it hit to the nearby service. So these are the 4 ways of lightning occurrence. Apart from that, there's an induction effect. Nearby lighting is there, say for example from here to the 1 or 2 kilometers away, but still the outer air, the induction effect is there. So you have to consider all these aspects. Right. Now according to the IEC 62305 standard, in Sri Lankan scenario is SLS 1472, and there are 5 pillars I just explained here. Unless you have all these 5 pillars, we will not say a lightning protection system. This is the many people in the world, not in Sri Lanka, they confuse. They said merely if they have a small sort of a lightning rod, and you have this copper tape, aluminum tape, and then ground it, everything is finished. No, my friends, it's not the case. You have here, your first column is the air terminal system. What is the role of it? You know now. Air terminal system is merely to grab or they capture the lightning energy or the lightning current, which is passing like, like a steps. We call step leader, remember? So the second one is, okay, now lightning air termination system, okay, it capture, then there should be a path to go. Stroke is traveling, you remember it, return stroke, when they are the charge exchange of charge, positive and negative. And then this down conductor, it can be the copper, it can be the aluminum, it can be the, for example, GI, whatever, these three are the mainly used. And that is the second part of the system. Okay, now we have air termination, now we have down conductor, now, and then earth termination system. So where the energy should go into the earth. Okay, the many people, maybe some people, they know only these three, but I just say the very, very important two parts that you will further understand later on when my slides moves on. So now separation distance is what actually? Now separation distance should be calculated between your lightning protection systems component and the nearby metallic objects. For example, suppose you have a antenna mast close to your building. So that distance, depending on the, suppose is meter 2 distance, for example, 2 meters away from the distance, calculate whether this separation distance is to be kept as it is or to be bonded to the system. If you don't bond, depending on the calculation, if you don't bond, if the permissible value is passed, then what will happen? Then there will be again that side flash can occur or the partial current. So that's a very important thing. Okay, the fourth part, the light key potential bonding. I will explain later on, or we will achieve through Surge Protective Device Systems. We call SPD. That's very, very important aspect. Okay, now I think I already explained this. This is the this is the you can see here the copper thing or whatever the term is also, and these are the down conductor part, and these are the earth terminals. Bonding, whatever the metal part, metal object, say you have here the AC outdoor unit, I will show later on. You have to bond it depending on the distance here. Okay, now let me you to explain very important terminology, right? So we call striking distance. Now you already have an idea. What is this? This is the last step of the lightning current. Steps are coming. Now this particular terminal or the air termination system should, at the tip, should be able to capture this last tip of the leader. This distance from here, the terminal to this step, we call striking distance. That's important, right? So that's why we try to intercept by introducing external protection mechanism to capture the lightning energy and disperse to the earth. Very, very important thing. So remember, when you select the suitable material, you should be very aware. You should follow our IEC guideline, the standards, or the SLS, or whatever the Indian standard or Bangladesh standard or the African standard, whatever you have to follow, the Nepal standards as well. Okay, now these are the type of air termination systems we'll find in the market. So if I say first, let me explain the non-conventional first, because there's hot arguments going on between this non-conventional type air termination systems and conventional systems. But let me stop that argument. It's not my scope of today's topic. We can talk and further later on. So these are the, we call early stream emission type non-conventional air termination. You have seen some of the buildings, they have already installed this kind of things. And here we call dissipation array systems. So especially in the USA and the America side, we will see this kind of things as well. But IEC 2305 or SLS 1472 standard merely speak about the conventional type standards. So you see now the 95% of the world, they speak about the conventional type. It can be the copper rod, it can be the rod, it can be the GI rod. So no matter these three materials, depending on the case, right? So these are the very, it can be sharp tip, it can be blunt tip, whatever, depending on the case. Okay, now the thing is this. Now you know this thing now, the capturing mechanism, it is been done by the air termination first, but now is the problem how to position this air termination. So there are three position methods of protection procedures we follow. The first we see the rolling sphere method. I will show you a small animation for you to understand. And the second method is mesh method or the protection angle method. Now, for example, let me explain you. Now, this rolling sphere method, I explain you, there are three different levels of protection. If you select the class 1 or the level 1 protection, you select the smallest radius level, that is 20-meter radius sphere. You will roll upon your building, all parts of the building. I'll show you in the animation. You will understand better. Now the level 2 is the radius is about 30 meters, and level 3, level 4 is 60 meters. Now you see, higher the level, higher the radius, and lesser the places of touching the building. So that means the cost is low here, and here cost is high here. That is one question. Okay. Now if you take the mesh method, you place your air termination. Air terminations are not merely vertical termination. It is a combination. It can be vertical as well as horizontal. Also, in nowadays, both plus horizontal is a sort of hybrid thing, right? So there are 5 by 5 meter, 5 meter by 5 meter mesh, 10 meter by 10 meter, 15 meter by 15 meter mesh, 20 meter by 20 meter. So these are depending on the class. You will see now if you select, for example, 20 by 20, you will have less money. So less copper or the tape or the standard cable will be required, for example. Now that is a scenario. Now the protection angle I have already given here, the graph also, the IEC 62305. But you see here, the protection angle for level 1 protection is 70 degrees, level 2 72, level 3 76 degrees, and level 4 is 79 degrees. Here also, the more the angle, the wider area will be protected by, the effectiveness is less. But here, the angle is less, effectiveness is. Okay, now we know those things. But through a lot of studies, now one scientist called Hart, Malaysia, he conducted a lot of research on this, and we also, together with Mr. Abesing, we conduct catching up one location in Sri Lanka, and in Rajagiriya, Royal Park building, and we have taken some of the measurements, and we have come to the same scenario and conclusions that where the sharp points of the building here is the more vulnerable locations for the lightning, right? So when you install your lighting vertical protector or whatever, so you have to first consider these locations. That's very important. It doesn't mean that the other locations are not happening. Yes, it happens, but it's less. You see now, if you take the B, the less than 5% chances are there to be hit when this is the first occurrence. Not because of the height, because of this situation. And see here the vertical edges. Remember even to put your copper tape for the down conductor here also, right? And the other like that, right? This is the first method, the rolling sphere. You see, you will roll on over your building, going further like this, other building. Where it touches everywhere, these locations are at risk. If these places are not risk. Now you see, that's what I am keeping here. These three, the 4 sizes of radius of the sphere: 20 meter, 30 meter, 45 and 60. Let me show you now the animation. Okay, here we go again. Now you see these areas are more vulnerable, right? So when our installation will take place, you have to consider to install the terminations, these locations. So do you see now after installation, you see now this ball will not touch to the building. I will animate it again. You see now, because of this terminal, in this scenario is this vertical terminals, the ball will not touch to the building. So the lighting will not occur, and this terminal and the down conductors will take over the job. For example, now here. So I think you understand. We don't have time to explain a lot of things. So this is one of the applications. This I have taken from my book I'm writing these days. Application of protection angle method. And this you have seen, this is actually similar to Sri Lanka Meteorological Department building, operational building. So you have, on top of it, there are antennas. So here we have put here mast here. So you will see I'm applying here the protection angle. So this particular antenna is very safe, you know. And here also, and mind you one thing, and this on the top of the surface, because of these two masts or the arresters, these two parts are marked here. Also, you can see they are protected. And if you go down towards, you know, to the ground, and this part also protected. Now you will come to the second method, that is we call mesh method. It is very easy. I already explained. These are the applications. You can see here. You have mesh here applied here, these two. Normally the mesh method is normally we apply for crack proof type buildings. By here, I applied here. Here you can find a small building like the machine operator room. Here I applied the application of both mesh method then and what you call the protection angle method. And so after we, now you know that, after all this already, this air terminals, so we have to do the laying of down conductor systems, right? So here, according to the level of protection, we place the down conductors. For example, if you take the protection one level, the level 1 protection, every there should be a down conductor. If you take the protection level 3, every 15 meters there should be a down. This is to carry the current we capture here to bring down to the earth. That. Okay, this is I just shown you. This is the practical scenario where we have used in Sri Lanka. We have used this in some of the villages, 5 villages. We have practiced this method together with Mr. Abhay Singh in 1994 up to 2007 or 9. We have done 5 villages. We have protected using very low cost method. We call in terminology we use is catenary lightning protection system, catenary wire. So you see here, I just put, it can be here like this, but normally the wires are, this is actually the metallic wire. It can be aluminum wire, it can be GI wire like that. You know, these are the GI pipes like that. But mind you, the protection is perfect. You can see the protection level of area here is very high. But the problem is, as I mentioned earlier, the separation distance between the house and this has to be calculated perfectly, and then all the metallic object and the whatever the things here in between this thing, if it's less than this distance, all items should be bonded. Otherwise, it will, the earth terminal of this also very important to be bonded to this termination. This is very important. Okay, now we have completed with the down conductor. Now we'll come to the third part of the protection system, that is we call grounding system. Now, why we need grounding? You all understand that at your home you have trip switch or the RCC, right? That will protect yourself, protect in order to avoid you to shock electrical current. But here also we can say first important thing is in order to not to pass your body lightning current, you have to first protect the people. And the second one is equipment protection from fault current. Here you have seen that you can watch here the main circuit breaker or the distributor is caught fire because of this problem, and that may be due to the bad wiring installation. So normally you know that we have to follow the IEC wiring regulations, IEC 60364, or if you take the IET regulations, IET 7671 regulations. But if you don't follow this, we'll find this situation, for example. Right. Now, what is that? Remember that fourth column of the building of the lighting protection system. Now the air termination finish, down conductor finish, earth finish. Now will come electrically connecting the two down conducting system and the conducting systems. So you can do two ways. The first is direct connection. You can directly connecting all these, whatever thing you directly connecting with the, say, the copper or the aluminum or whatever, right? If it's outside, if it's underground, always better to use copper. And I mentioned here connection under specific condition. That specific condition I will explain little later, right? Just for a while, just say why you do this. To achieve equipotential building, the bonding. The equipotentialization is very important. Now, what will happen when the lightning hit to the building? If there is no bonding taking place, even you have a lightning protection system, even you have a surge protective system, but if you don't apply the bonding mechanisms, so there will be different voltages induced different part of the building. So remember, very basic science, if there's a differential voltage, so there will be current passing through from one place to the higher voltage to the lower voltage. That's a very simple science. So it's not rocket science in this lighting protection, only simple science. Right. So how would you achieve this? Now, I have mentioned here, these are the three main parts of a light earth electrode. We call earth electrode, or some countries like US part, they use, instead of earth, they use ground. It's the same. But in our British colonies, we use earth electrode. Earth, the parting is earthing, whereas they use the ground. It's the same anyway. Now you see here, number one is the earth conductor, which is coming from your structure, your home or a building or a communication tower, whatever, right? It can be copper, for example, right? And part three is the electrode here. Here is a vertical copper or GI rod. But I use rod here for the simplification, but it can be either a mesh, I'll show you. It can be a sort of what you call the plate or a combination. And here, now the part two is the very, very important thing. I mean, 1 and 2. This is the connection between this conductor and the electrode. Remember, lighting energy comes here from the top to the earth through this electrode. What happened? But if the connection between the electrode and the conductor is corroded, for example, many places I have seen with Mr. Abesinger and visiting surveys, that this particular connection is very poor. So what will happen? That total energy or the total lightning current will not disperse to the earth. Then there will be arc here, there will be problem, right? So this is the how it goes to the thing. Now this is the cross section of this scenario. Okay, now we'll follow IEC 62305. There are two main type of electrodes, earthing mechanisms or the earthing systems. We call type A earthing. Type A earthing can be vertical electrodes. It can be any electrode, the rod or the plate or a mesh or a combination, whatever, or the horizontal. But nowadays, and here I've just put you, here you have a building, you have here earth electrodes 1, 2, 3, 4, 5, right? So what happened? All are bonded together. So that is horizontal thing. So this is the combination of vertical plus horizontal, right? It can be either one or the combination. You understand? So what is the guideline or the standard says? But normally, if you have a structure, the distance between the earth electrode should be kept minimum as 1 meter. And the depth of about half a meter or the 50 centimeter. And here I have put a very good thing. And here, this is a natural conductor. You know, the many people, even the construction field people, they decide the lightning protection system after the risk, after the disaster occurs or after the damage occurs. It's not the scenario. I think we have been, pointing out this matter since 1990s to the ICTAD people, and they have conducted a lot of workshops also in Sri Lanka and in the other part of the world. And Dr. Chandima Gomes is one of the scientists who conduct a lot of awareness programs around the part of the Asia as well. All this awareness about the lightning protection system. Now, at the beginning of your foundation work of any structure on a building, if you can start this work at the very beginning, the lot of cost can be reduced and lot of aesthetically damage can be also minimized, because many of the architects, this is the matter of with the architects, the discussion between the architect and the owner, right? So many of the architects don't like to have many things on top of it. That's true, even the client, right? So if we do at the beginning, very beginning at the foundation, the minimum aesthetic disturbance will occur. Okay, these are the type of earth electrodes we'll find. I'll explain you. This is the plate here. This is the first. This is the radial thing, ring earth. And this is the mesh type of thing. Mainly they are used in the data centers. Here I have enlarged here. This is the race flow mechanisms. They use here this kind of things. These are, remember, each and every part is bonded to this whatever the metal thing. So everything is, there will be no differential voltage in between. Everything is equal. If it's 100,000 volt, 100,000. If it's 10 kilowatt, 10 kilowatt, no issue, right? Right. So this is the, after you placing all this equipment, the buildings, it looks like this. There are termination systems, you can see, down conductor system and earthing systems. Here I forget to bring down the ring earth here. There should be a ring here. I forget. I'm sorry for that. This building, these two I added, but this I forget it. It's okay. Right. Let me just show this slide to the researchers. So when you design a system, you don't tell it what is the successful, the rate of this this system, unless you get hit. But mind you, this is a probabilistic approach, what we did. When we calculate the risk assessment, and during the risk assessment, the probabilistic values will come. The lightning is a probabilistic nature thing. So how do you test the system? So these are the things. We do some simulations. This is actually a sort of network of impedances or the resistance. So you can apply some current here, that 100 kiloampere, whatever. See how the current distributes each and every. So you can understand with one lighting rod or the lighting protection termination with one conductor cannot do anything. Depending on the dimension of the area, depending on the number of rods, number of and number of earth timbers. That's very important. Okay, now my final part, let me have some water. So why we need a surge protection system? I already explained in my very first slide of this presentation. When the lightning hit, for example, in this scenario, the trees here, lightning is hit here, or it can be a communication tower, it passed to these things. So I already explained you now, you know. Now, in order to avoid the secondary effect of lightning, right? The first part I have already this thing I explained the direct effect to avoid. Now this is to avoid the secondary effect. Now if you take the power, for example, now normally in our part of the world, especially the British colonies, all use this kind of 230 volt 400 system, right? So normally you will find this sinusoidal AC wave in the frequency is 50 hertz. And if you go to the other side, for example, US they use 110 system with 60 hertz, like that. But not always you will find a very nice or clean power. What will happen? There are a lot of disturbance to this, alternative system or your power system. I just grabbed here some of them. So mind you, lightning surge protective devices normally we install to avoid such a disturbance. Not only lightning surges, also some outside disturbances like the operation of inductive loads like welding plant if you have, for example, maybe the heavy machine loads, then your power system will get disturbed. So these are some I just show down here. Voltage dips and temporary voltage rises, switching thing when this normally this switching occurs, especially the inductive loads such as things are welding plants are operated. But here remember the value, the maximum value here I put here 6,000 here, for example. In the next slide you will understand. Now your normal situation, normal scenario, all this equipment should work in this green region. If you take 230, but normally 230 can go up to, for example, 255 volts or 275 volts, but it should not come to the purple region. We call the degradation region. So when it comes to degradation region, if it longer the time, then the equipment, especially the sophisticated electronic equipment nowadays, will get damaged, but slowly, right? And if it enter the catastrophic failure level region, like in red region, definitely, immediately, the things will burn. So this equipment damages will mainly due to these two. Whether it is in the purple region or the degradation region or the catastrophic region. So you should be careful about that. So what are the transient? It can be from the lightning or switching of large industrial loads. Also remember, we don't have time to explain electrostatic discharge. Those are the 4 things we have to minimize. Okay, what is the function of a surge protective device? We call SPD, right? So here the transient overvoltage is there, the peak is there. If I don't intercept in between the power line, this is the live line, this is the neutral line and the earth line. If I don't intercept this, what will happen? This entire energy of the surge transient or voltage will go to your load, your equipment, critical load. So it will damage. So what is the purpose of this? This will absorb the energy and it will pass to the earth without damaging to your load. That is the behavior or the role of a surge protective device. Now, for example, let me explain you further. If the surge comes, instead of going to the load, So it passes to the earth actually. So whatever the excessive part and only the needed part will pass to the load. This is the role of a diverter or the surge protective devices. Okay, what is our basic assumption? Basic assumption is 100% of the lighting energy or lighting current when it comes to a structure. Now, in this case, we have a lighting protection system here. It can be, there are places, you don't have most of the places, but suppose I just throw a lighting structure with a lighting protection system. Okay, 100% of the energy of the lighting current, if it comes, 50% will go to the earth. Remember, very well, important point I'm giving you. If your earthing system is perfect, 50% of the damage you can minimize. What you should pay attention at your home when you go back to your places, please check your earth, whether it is corroded to that particular to connections. You can minimize whether the earth is okay, your resistance value is okay. And the other 50% pass to all the service line. Here I only mentioned the power line. It can be communication line, it can be data line, it can be antenna, whatever the metallic things it shares, right? So this is our basic assumption, right? Now, according to IEC standard, normally in the SPD, instead of IEC 62305, the number 4 part, we use another part we call 61643, IEC 61643. Right? And Sri Lankan standard is SLS 1473. So it will go. So now the things, the best lighting and surge protection concept will be effective unless it embraces every incoming. So we have to protect every incoming and thing. So this is the things. So these are the coordinated electrical electronic equipment. So the 4 kilowatt, then it comes down to the, when it comes from the outside, from the service providers, electrical service provider, then when you come to the inside the building, say the second side, I mean the distribution panel will bring down to 2500 volt. And then at the end point, the sustainable level is 1500. So protectors should be selected accordingly. So I don't have much time to explain all these things. So these are the normal pattern of how the power line protection is. You see now here the main protection distribution, and this is the sub distribution level, and this is your endpoint. So normally, as a rule of thumb, normally if you have your main distribution panel here, if you have your sub distribution panel, if you have the distance between is more than 30 meters, we use 2. Otherwise, you can have only 1. Okay, this is my last slide, and this is actually an example of the protection of a communication side. Now here you can see you have the structural protection here, and you have down conductors, you have earthing system, all are bonded, and these SPDs are given to the base stations. Okay, thank you very much. And let me just put my other sides, and as we have already planned to deliver this book to the workshop, and this book is under printing, and very soon once it come out from the printers, we can share with you. Thank you very much.
Thank you very much, Engineer Nwan Kumar Singh. I think you highlighted a lot of important areas that we need to be focusing, and probably we are not giving the adequate attention in the engineering designs or architecture, or and then as a disaster prevention measure, there are a lot of things probably all of us should be thinking and adopting in our designing and implementation work. So it's well done, and I think it's a great presentation. I think we had a lot of material coming from the 2 presentations. So the next item we have is a short panel discussion. Let's try to keep it around 20 to half an hour. So let me introduce the panel. Basically, the panel will be chaired by Mr. Sarath Premalal. Let me introduce him first and then introduce the panel members. Mr. Sarath Premalal is a meteorologist and he was a former Director General of Meteorology, and he had been there 30 years. And Sarath obtained his bachelor's degree in physics from University of Peradeniya, and he has 2 masters, masters in physics from University of Peradeniya and masters in meteorology from Reading University, United Kingdom. And he had been engaged in many national and international projects on meteorology, climate change, and published a wide variety of research articles and weather prediction related material. And he had been helping on many, many projects in Sri Lanka. At the same time, he had been transferring his knowledge through student advising, graduate student supervision in a number of universities, including University of Peradeniya, University of Rona, University of Sri Jadanapura, and University of Colombo. And internationally, also he worked in SAC Meteorological Research Center in Dhaka, Bangladesh as a scientist. And also he is serving as a guest professor in South China Sea Institute of Oceanology in China. Presently, he also contributes as a technical advisor to the World Food Program in Sri Lanka. So he has a lot of wide experience, and he'll be chairing the panel today along with a number of other members. And let me, I introduced 2 members already, Dr. Shiromani Jayawardena and Engineer Nuwan Kumarasinghe, and then we will be joined again in the panel by Mr. LSB Karunaratne, the Deputy General Manager, Power and Air Conditioning in Sri Lanka Telecom. Mr. Karunaratne holds a bachelor's engineering degree in electrical and electronic engineering from University of Peradeniya, and he is a chartered engineer and a corporate member of Institute of Engineers of Sri Lanka, IESL. And he had been working more than close to 30 years in power and air conditioning, power protection network improvement, PABX systems, among other things. And he's often he's been consulted often on lightning and surge protection, and communication systems, earth energy management, and electrical distribution systems. So he has a wide variety of experience in designing and protection. So he'll be joining us in the panel. I'm not too sure Mr. Abesinghe is still on the line, and he's most welcome to join the panel if he's connected. So then in the panel, we have Mr. Kumarasinghe and Dr. Shiromani Jayawardena, Mr. Karunaratne and Mr. Abesinghe, and then Mr. Karunaratne, and the panel will be led by Mr. Sarath Premalal. Sarath, to you, please.
Okay, thank you, Dr. Anand. So actually very informative presentations done by Dr. Shiromani and Mr. Nuwan Kumarasinghe. So I just summarize all the presentation. So it covered science, physics of thunderstorm and its impacts, climatology and atmospheric dynamics, and finally the lightning protection. So I am sure all the presenters are having vast knowledge on this subject, and still many things to be explained by them. But I think so we don't have much time to explain all the slides and others. Unfortunately, Mr. Abesinghe cannot present his presentation. However, Mr. Nuwan managed to present his presentation. So the presentation, the Nuwan's presentation, he explained the physics behind the development of thunderstorms and how it strikes the humans and possible causes of death. And in addition, he also explained, that many things about lightning protection. So the Dr. Shiromani's presentation, it starts from global to regional and then local. She mostly focused to lightning climatology in Sri Lanka and possible reason for the development of thunderstorm and the atmospheric dynamics behind the development. I think some questions also came about this dynamics and others. And it's by a spatial distribution. As he said, sea breeze, convergence, and orography play an important role in developing thunderstorm in Sri Lanka. So, but the other countries like Bangladesh may be different. You know that the development of thunderstorm will be different. The dynamics will be different. So, okay. So now we'll just go to the panel. So there are many questions came from the audience. So with the limited time, I would like to forward selected questions, and all questions will be answered by our expert through email within a week if something we cannot explain today. So the first question I just forward to Dr. Shiromi. So some participant asked about GLD 360 data. So is it possible to get those data? I mean, that is, it is available in the web. And the other one, is there any specific atmospheric parameters for forecasting lightning? So we know there are many, systems to predict thunderstorm, like convective available potential energy, K index, something like that. So I think in addition to that, so are there any systems to predict lightning? Yeah.
Thank you, Mr. Premalan. First, actually, we got this GLD 360 data through a project, a pilot project, collaborative pilot project from Sri Lanka and Met Department and Finnish Met Office. So it's not available online. So we got from this project. Second question is actually some of our colleagues from Department of Meteorology, they conducted several research to see what kind of parameters we can use for thunderstorm forecasting. Usually there are few thermodynamics indices like CAPE, stability index, like lifted index, K index, and they found that CAPE is not a decisive parameter for Sri Lanka, but K index is more reliable index compared to the other indices. And the Finnish government also using our GLD 360 data, and they conduct one research using machine learning techniques. Actually, they have put many parameters and found try to find a good correlation, but they said that they found only good correlation in surface temperature. So not any other parameters did not show good correlation with our lightning and these parameters, no good correlation. Any other questions?
I think that's all for the first round. So we are going to take this 2 rounds.
Okay.
So then second question goes to Nuwan. I think so many questions came to Nuwan. So especially regarding the communication towers. So many people asking, you know, that communication towers are much vulnerable for the lightning. I mean that people living in the around the communication towers. So that is, you know, that's some people ask. And the other one, so I will just combine everything and tell you. So then, so you can answer, I think directly you can answer for the questions. And the same time, I mean that the satellite TV antenna. So actually we want to know the satellite TV antenna and lightning, I mean that communication towers are vulnerable for lightning strikes. I mean the people living in the living around around the area. And so I'll just elaborate, you know, that the equation, if lightning strikes a communication towers, a large amount of lightning current can be dissipated in the earth near the tower, causing severe earth potential, right? This is a common concern among residents who live around such towers. What is your recommendation in addressing this situation? That is what the question, I mean that question asked by one participant. So can you answer that question first?
Okay,
Yeah,
thank you very much. Let me tell you very beginning that actually I have seen now only I'm checking the questions actually. So there are a lot of questions coming from the audience, the viewers. So one thing, I think Mr. Anuka and Mr. Skandaraja, I forget to mention his name, Mr. Skandaraja, engineer Skandaraja from Pell Electric, either one of the sponsors or the main sponsor for a workshop which was supposed to held in 17th October. And they are noting down, and all the reply for the all questions will be sent through email if the time is not permitted. That I should say, I have seen a lot of questions. Okay, answer to question. The first thing, so the communication tower, yes, that's true. So what will happen without communication towers, we cannot live. That is the first thing, especially now. If you don't have communication, how can we conduct the meeting? So today, that is the thing. So that is our sustainability. So we have to survive with those things. So we cannot, so without communication towers or without communication entities, we cannot live. Now, what is the question? But the lighting is, as you know, that it's a natural phenomena. When the lighting hit to the tower, I explained you. So there will be huge potential difference between the top of the tower and the ground. So that particular one, suppose if the lighting current comes, for example, instead of 200, suppose it comes 100 kiloampere. So how many megavolts? So the lighting tower is a metallic object, and there are so many metals are there. So what will happen? Instead of resistance, there will be some inductance taking place. So the copper normally have 1.6 microhenry per meter. If you have 100 meter one, so say how many inductance is taking place. So through that particular metallic object, we have the voltage of L times di by dt. That is the equation. So that is di by dt is the rate of change of the current. So I times R is the normal resistive voltage. So huge voltage. That means on top of the tower and the ground, there will be megavolt level voltage difference will be there. So what will happen? That megavolt, you remember the breakdown of the air is how much? 3 megavolt per meter. That is the electric field. So if the breaking voltage, if it passed the limitation, there will be arcing take place. So with the arcing taking place, there will be huge induction and the induce of the lightning current will take place, all the things. That is the one part. Second part, when the lightning current goes to the, huge lightning goes to the earth, then normally the communication scenario, according to the Sri Lankan scenario, the TRCSL, they have already their guidelines, and the operators of the tower are asked to bring down their earth resistor, the impedance value, as low as possible and according to the given radial way or the minimized step voltage. Those are the things. If you minimize the step voltage to not to go further away from the tower, then the minimum defect will affect to the building. But suppose if you find in the vicinity the earth terminal, then that particular light current will go pass through your earth terminal and enter your building. Then the house or the building will get damaged, or your main panel or whatever. So those are things. So you can minimize, right? You cannot avoid communications. We have to live with this, right? The COVID, we cannot avoid. We have to live with this. So what we do, I recommend, normally, as per TRC, Sri Lanka Telecommunication Regulation Standard, and the other countries' regulations as well. So normally tower providers, they should have guidelines to minimize their resistance level. And then in order to avoid, you have to apply equipotentialization to apply in the surge protective device. Then only even the induction is high voltage, if you have this SPD or the surge protective device, so that will take care on the huge energy. That's how it minimizes. I think I answer the question.
Yeah. So I think you so we got the answer. So how do you think your use of clamp type ER meters instead of probe type meters, as in some locations such as rooftop towers, etc. And is it possible to use GI pipes instead of copper rod? So I think we also talked much about that. So can you
Okay.
answer for those two questions?
Yes, Mr. Premalal, let me answer first the GI and copper thing. So as my time, as I beginning, I told you that the time is not limited. In fact, I have taken a lot of time from you. So, but thing is, GI, yes, you can use. Copper, you can use, no issue. But only thing is, depending on the class, depending on the diameter of the GI pipe, the earthing effectiveness will depend. I have seen the question on the screen. So that is my answer. Yes, GI you can use. For example, at the rule of thumb, we use, for example, 2-inch diameter GI pipe or even higher, depending on the case. And the conductor have to be bonded very well to the earth electrode. That can be used, definitely, no issue. And your second question about the clamp meter, I think Mr. Ranatunga from TRC, my friend. So yes, in Sri Lanka case, we have, I forget to mention because of the time limitation, normally in Sri Lanka and this world, in India especially, and even Bangladesh, so we have the TT system or the power distribution, we call TT system. So the earth terminal will not bring to your premises. So your supplier will not give you earth terminal. There's no earth wire. You have to provide your own earth. So because of that, you have to, but normally how the earth measurement is done, earth measurement is doing for the reference earth. So the reference earth is not provided by the provider. In Sri Lanka scenario, CEB or the lake or whatever. So what will happen? So you have to put your earth rod, whatever they are, and then get measurements, right? But earth clamp meters are not recommended for TT systems. You will get earth loop resistance, not the earth resistance of the earth impedance of the particular individual earth. So I'm not recommending clamp type earth meters to use in Sri Lanka because of this. But there are cases in Sri Lanka and other our part of the world, they use, instead of TT, they convert to TT into TNS system. Yes, in the case of TNS, you can use earth clamp meters.
Okay, thank you, Mr. Luan. So the last question, so I'm not going to raise the question to Mr. Abesing, so we don't know whether, so we can connect him. The last question for this round. So the next round, maybe that 5 minutes or 10 minutes. The first round, the last question goes to Mr. Karunaratne. So Mr. Karunaratne, so other speakers and panel members presented and explained the key areas of the subjects. So lightning protection and science and others. So requirement for development, approaching methods to minimize failures, formulation of regulatory bodies, etc. etc. So would you like to add more based on your experience? So you have many experience about, I think, this subject.
Thank you, Premalal. Before commenting this one, I would like to say something about this earth clamp meter, because earth clamp meter, basically, that meter can only be used for the countries where service providers provide the earth connection to the customers. For the it basically read the loop resistance of the, basically it provide the loop resistance of the path. So in Sri Lankan environment, we can't use this clamp type earth system meters. In telecom also, we also tried by getting a sample, but it provide the only the loop resistance meter. It can read only loop resistance. The other thing is I want to mention about the this for the benefit of the participant who are in the communication field, because we have standards called ITU standard. It will provide the comprehensive guideline about the requirement of installation, also maintenance of the communication system, such as radio base station, CCTV systems, customer premises, telephones, instruments, data circuits, etc. So if one want to know more about this one, you can refer the ITU K series guideline. There are K1 to K125 described in the detail explanation and also the guidance of installation and maintenance. Regarding the this problems question asked by the Mr. Premalal, actually in Sri Lanka we have experienced lack of expertise in this field. So also we don't have a proper regulation on this field. But in the telecommunication, we have a TRC, in the electricity board, we have a PUSL. Likewise, there should be a regulated body for this field. The one more thing to add this the Nuwan and the Shiroman explained about this subject matters. One important thing is to if you have installed the lightning protection system, you can't forget this one. So you have to maintain the preventive maintenance has to be carried out to provide the service. Smoothly. That means that we are looking for the actually 100% uptime. So so maintenance is very important. Depend on the critical needs of the service. If it is a data center, the frequency is more. The other thing is providing a lightning protection solution, we have to consider the total solution rather than focusing on one area. We have to put a terminal, external LPS system, surge protectors, according to this IEC guideline. For in case of this telecommunication, we have to follow the ITU guidelines. Thank you.
Okay, thank you very much. So the last round, second round, I think so you better answer very short. So actually, I'm expecting a very short answer for this. So because we don't have much time. So usually the thunderstorm starts in April. I mean, start in early October in Sri Lanka during second winter monsoon. But this year, so thunderstorms started little late, nearly 1 month late. So it started in November. So according to my experience, just wait. Yeah, according to my experience, it looks very severe thunderstorms during this month. Yeah, even yesterday, so there was a very huge today in Bangladesh Daily Star paper. So given by former director BMD Dr. Karmakar, he said in this summer season, unusual thunder activities occurred in Bangladesh even. So the second question goes to Dr. Shiromani. So as I know, you are a good researcher on various disciplines in the field of meteorology, and you conducted many national weather prediction and El Nino Southern Oscillation, IOD, MJON, and etc. So how do you think that different climate modes such as IOD, ENSO will impact lightning activity in Sri Lanka? So just give a quick answer.
Thank you, Mr. Premalal. There are many studies has been done to see the impact of rainfall and impact of IOD and ENSO on rainfall variability, but very limited studies has been done to see the lightning activity. There are few studies conducted for the South Asian region, and they found during El Nino there are more lightning activity than La Nina. So this year also La Nina year. So actually in October generally intermonsoon is the transition period between two monsoons. So there will be no prevailing winds and light winds, and daytime heating will enhance the convective activity to produce this lightning. But this year, actually, even during the October, we found the strong monsoon winds over Sri Lanka. So that's the reason we didn't get much lightning activity during this year. Thank you. Hello.
Hello.
Hello. Okay. Thank you very much. Mr. Kumar Singh, so you mostly talk about lightning protection. So
Yes.
do you have any idea about how your knowledge is linked to Sendai framework for disaster risk reduction? Actually, many people are talking about that and it is a UNDRR agenda for 2015, 2030, 2030 agenda. Because as a country, we are committed to reduce mortality rate, affected people, economical losses, and finally build back better. So could you briefly explain it? Don't take much time back because time has passed.
Well, that's a good question, actually. So regarding this Sendai framework disaster risk reduction thing, so yes, you have to see the priorities of the Sendai framework of this. So there are several priorities. So we can apply it even for the lightning as well. So even they talk about all the disasters, not only lightning, the flood or hurricane or cyclone or whatever. But as far as lighting is concerned, you have to see these priorities, and first you have to have the very essential thing is a database. So as Dr. Shiromani presentation and Mr. Abeysinghe's presentation, they have already mentioned the vulnerable locations in Sri Lanka and other part of the world. If I talk about on Sri Lanka scenario, so first, yes, we have a database mechanism in Sri Lanka, but I may say it's not quite elaborative manner it is done. So we have to improve this aspect very well. So once you have the database, improved database, yes, we have, of course, under the UN organizations, we have a death inventory database for DMC, for the Disaster Management Center. So, but still, I think the input of data, of the lightning concerned data, is not in appropriated manner. So that is the first answer. So we have to concentrate on more on that. So we know already now, Shiromi's studies and Mr. Abeysinghe's and other studies, already we know, even I studied in 2012 on the UN project. So we know the vulnerable areas, but the data collection is not, that is very important thing. So data collecting is one of the aspects. And then we have to collaborate with mainly for the other institutions, not only the government institution, because there should be a regulatory body for the lightning aspect as well. So I think there should be a government body, maybe the Disaster Management Center, maybe the Meteorological Department, Sri Lanka, or the Arthur C. Clarke Center, whatever. In collaboration with the universities, in a collaboration with the private entities, there should be public-private partnerships, because they can help us. They have a lot of ideas, the private parties. You can regulate things, the government can regulate. So you have the university body, you have to integrate all these things, research people, especially the university people, students, researchers, all throughout the world. And we have to get down the knowledge from the researchers outside the world and Sri Lanka. For example, there are many researchers within our region, for example, India, Nepal, and Dr. Karmakar is listening, I think, and Dr. Madan Lal is there. So there are a lot of people. So, and even Dr. Chandi Mugumus, he's doing quite well in Africa. So I know. So those experience, especially the chap or the director of the from Africa, Ms. Lubasi, she's doing a wonderful job with Dr. Chandima Gomez. So we can share this information. That is important. And we can improve this, integrate all these things, and then go to the vulnerable areas and implement this aspect. For the implementation, yes, we can get the participation of the government, more than the government, the private entities, right? And the NGOs, UN, we can get advice from the UN organizations. The money will come. The first thing you have to have a legal act. I know in Sri Lanka's case, in our UDA Act, the lightning protection system is a must. It's a compulsory item, but practically we cannot implement because of the lack of the concerned people. So because of this, if we have these things together, we can go for we can, have a proper system, then we can have the build back better system for Sendai framework in response to the Sendai framework. Thank you.
Okay, thank you, Mr. Nuwan. So the last question for Mr. Karunaratne. So in real life scenarios, damages to communication electronic equipment are getting increased and service are interrupted due to the lightning and surge related issues. So what is your advice to newcomers to the field of minimizing service interruption and damages? So just answer within a very short time. So because we don't have much time. Okay, Mr. Karunaratne.
Okay, Pemlal. Actually, the most of these installations are not done according to the standards. So I advise and I recommend newcomer to study the requirement as a total solution and prepare the plan by considering the site condition, critical details of the service, and identify the vulnerability of sites, and design the requirement according to the plan. And also it is required to implement the plan according to design. The most of the cases we have experienced that the plan is nicely done, but the implementation is not in the recommended level. So for newcomers, it is better to go through all the relevant standard during this study and plan the work accordingly, and implement the plan according to the design. So also after completion the installation, it is needed to check and test the installation this LPS installation and speed installation are matched with the design. So there are standard for the international standard as explained by the Nuwan and the IEC 62305 in the whole area. For the telecommunication sites, you can follow the ITU guideline. So I think if we follow this guideline standard, the installation is actually well standard, and the installation is well protected. I would like to add one more thing about the one question raised by the participant about the using of mobile phone. As I am from the communication side, I thought I should answer for this question, because actually mobile phones are not attracting lightning. So actually it is safe to use the mobile phone during the thunderstorm, but in the inside house, because this thunder is represented by the impulse in the Fourier series. So as this mobile phone is an isolated device, there's a highly unlikely to get the strike by during thunderstorm, unless it is plugged to the charger.
Okay.
Okay.
Okay. So thank you, Mr. Karunaratne. So before hand over to Dr. Chandana, Secretary ADREAM, for a vote of thanks. So I would like to invite Professor Dong Shaw from China Sea Institute of Oceanology. I think he has some that experience about thunderstorm in China. So Professor Dong Shaw, can you just explain your experience about thunderstorm?
Thank you, Chairman. I would like to deliver pieces, some information in China. First of all, we done lots of field observation by Chinese scientists from Chinese Academy of Sciences, mainly from IIP, which sir, you already visited a couple of times before. Of course, we are suffering similar lightning disaster in coastal China, because the convecting system migrated from the ocean to the land. This is first piece of information. Second, because we already have a China-Sri Lanka Joint Center for Education Research, the campus from University of Hunan, and we have a very good field observation facility over there. So I would like to invite some scientists from Sri Lanka, some colleagues, around this Southern Asia countries. Could you join our field observation in the near future? And the third one is because we already have another international forum we call natural disaster radiation. It's under the we call the Belt and Road Initiative, and also we have a very good cooperation with UNEP and other international organization. We call this organization under the Belt and Road Initiative ANSO, ANSO. Later, I will forward the information of ANSO to every participant in this meeting. I think ANSO can provide a lot of opportunity for the cooperation for field observation, knowledge exchange, even meeting or visiting scholars, something like this. So I would like deliver such 3 pieces of information by Chinese side. And most important, we already have very good experience in cooperation with our Sri Lanka colleagues regarding the earth science, regarding the oceanography, ocean disaster, marine meteorology disaster radiation, and something we did excellent work. And thanks to Sri Lanka government and the Sri Lanka colleagues, strong support to us. Thank you very much. That's my information.
Okay, thank you, Dr. Professor Dong Shaw. So actually, you are supporting very much for even our association. So I know, so you are supporting many students in Sri Lanka in your institute. So again, thank you very much, Professor Dong Shaw. So Mr. Abhay Singh is now in line. So just Mr. Abhay Singh, so just if you're okay, if just explain about.
Yes, about
ball lightning.
Yes, actually.
So,
can you hear me?
Yeah, we can hear. So you have many experience about that.
Yes, actually, the lightning, the number of size shown by Mr. Nguyen, actually they have only the streamline lightning, but sometimes when the lightning is very, it brings very. Can you hear me?
Yes. Yeah. We can hear you.
Actually, yes. Very good. Actually, lightning normally when it comes, it brings a large current, about 200,000 amperes. So it heats up the atmosphere very quickly in a very short time, like 20 millisecond times. So it generates a very large amount of heat. So due to heat, some parts of the atmosphere, some parts of atmosphere get heated up and they charge. So then because of the conductivity of the atmosphere, this charge atmospheric parcel starts moving from place to place. So from far, they see like just like balls of colors. There are blue color ones, red color ones, like that. So they look like balls. So therefore, it is called ball lightning. And actually, they are the charged particles of the atmosphere, which are in the shape of a ball. So this object to a tree or some conductivity, it will be earth. So they look like balls. Because of that, they are called ball lightning. One thing to add, actually, these are not going along straight paths. Most of the time they are going the zigzag paths. One thing is they look very beautiful, but they're very dangerous to touch. So touching means the static electrical parts will flow through our body. Therefore, touching is very dangerous. So just let it go and earth somewhere. Thank you.
Okay, thank you, Mr. Abesingha, and thank you all the panelists. So for fruitful discussion about lightning and lightning protection. So I would like to hand over the floor to Dr. Anand to close up the session.
Thanks, Sarath. Thanks for heading the panel and conducting this question answer session. I think we have come to the end of the whole workshop event, but I'd like to thank the whole panel, Mr. Premalal, Dr. Jayawardena, Engineer Kumar Singha, and Engineer Karunaratne. And then I'm really glad Mr. Abesingha was able to join at least at the end and add value. So thanks again, and thanks Mr. Premalal for the panel. And let me, this event was collectively organized by the Association for Disaster Risk Management Professionals in Sri Lanka and the Huddersfield University. And Dr. Chandana Siriwardena of the University of Moratuwa was the person who is coordinating between all these players and making it happen. I'm inviting Dr. Chandana Siriwardena to deliver the vote of thanks. Chandana.
Thank you very much, Dr. Ananda. And then at the end of our very first webinar, and then I think it's a huge success. Which is the first of our many webinar series on DRR. And as the Secretary of Association of Disaster Risk Management Professionals, I would like to thank a couple of people. Without them, this event won't be a success. First of all, Major General Sudanta Ranasinghe, despite his busy schedule, he graced our event and then gave us a small speech, and which we really appreciate, and thank you very much, sir. Your support and motivation is very valuable to us. And secondly, I would like to thank Professor Dilanthi Amaratunga, she's a huge strength behind most of our events and in providing the technical support from University of Huddersfield. And how can we forget our experts, Mr. Nuwan Kumar Singha, Dr. Shiromani Jayawardena, Mr. Abesingha, and Mr. Karunaratne. Thank you very much for sharing your valuable knowledge with us. And because of you, the experts, we got more than 100 participants, which is a great thing. And then I would like to thank the president of our association, Dr. Ananda Malavatantri, who initiated this webinar series with Mr. Sarath Premalal. So Mr. Sarath Premalal is the main driving force behind this webinar series and getting everyone together and then making it a success. Thank you very much, Mr. Premalal. And then how can I forget Mr. Anuka Vitanage, and then from IUCN, and Mr. Malit Senaviratne from Huddersfield University, UK. These young bullets, they made this happen because none of us are physically at one place. We are in the different places, but still we have managed to get this done. Finally, I would like to thank all the participants. We were able to get more than 100 participants at one point, and then thank you very much for attending this, and hope to see you again in a next webinar. Thank you very much. Have a great night. So Dr. Ananda, I think with that we can conclude the event, isn't it?
Thank you, Chandana, and have a wonderful evening, everyone. Thanks again.